Hi students, today I am going to explain linear combination of atomic orbitals. We know what are atomic orbitals. In an atom, the electrons will be revolving around in a shells, that is called orbitals. We know that. So when these atomic orbitals combine together linearly, so there will be formation of molecular orbitals. How it is formed? What is this concept? Let's understand. So linear combination of atomic orbitals, its abbreviation is LCAO. So in quantum mechanics, electron configurations of atoms are described as wave functions. So whatever is the electronic configuration we write for the atoms, here it is described as a wave functions. So during the formation of a molecule, orbital wave functions are modified. So when these atomic orbitals combine to form a molecules, these wave functions will be changed. How it will change? This means the electron cloud shape will change according to the type of atoms participating in the chemical bond. So this electronic cloud shape will be modified or changed according to the what type of atoms participating in the chemical bond. Let's see it elaborately, you will understand. So chemical bonds are formed by overlapping of atomic orbitals. When these atomic orbitals overlap each other, I already discussed this overlapping in the case of head-to-head overlap in sigma bond and pi bond in my last video. You can just check it to understand this one. So chemical bonds formed by overlapping of these atomic orbitals is visualized by linear combination of atomic orbitals. So the number of molecular orbitals formed is equal to the number of atomic orbitals included in linear combination. So how much number of atomic orbitals are included in this overlapping, that much number of molecular orbitals will be forming. So let's consider one example to understand it easily. So let's consider two atoms A and B. So when we take two atoms A and B, and by combining these two, we will get AB molecule. So atomic orbitals of each atom, I already told. So the electronic configuration here in quantum mechanics, we describe it in wave function. So atomic orbitals of each atom, A atom is psi A and psi B, wave function A, wave function B. So we can combine these two wave functions in two different manners, in a constructive combination, in a destructive combination. So constructive combination having same wavelengths, they combine together to form a big wavelength. Let's see, it is called constructive. It will have same phase difference between these two. So they will produce a new wave which have maximum amplitude. So this is A plus B. And what about destructive wave function? These have 90 degrees phase difference. See, we can see here they have two different phase difference waves. So what happens? They will cancel each other to form a line. So this is a destructive combination and this is a constructive combination. These are the two types of combination taking place in a linear combination. So let's see the two. Constructive overlap is also called addition type of overlap and destructive is called subtraction type of overlap. Let's see first what is addition overlap or constructive overlap. It is also called positive overlap, plus overlap. So plus means plus positive lobe of sigma wavelength of A overlaps with positive lobe of sigma B. So wave function B to form a molecular overlap. So both positive lobes will overlap to each other to form a molecular orbital because they are both positive and they are combining to form a molecular orbital. The resulting molecular orbital will have very less energy. So the resulting will have lower energy than the respective atomic orbitals. When we compare the energy of the respective atomic orbitals, the molecular orbital will have less energy. So such type of molecular orbitals are called bonding molecular orbitals and represented by sigma B, small b, or psi B. So when we take S shell, so S A it is B. It is two atoms, a positive loop and a positive loop. Both will combine together form sigma 1s, that is bonding molecular orbital. So this is constructive phase. Constructive overlap, just I told, so same wavelength, same phase difference, and new maximum amplitude wavelength is formed. This one. Next we will understand what is subtractive overlap or subtraction overlap or destructive overlap. It is also called negative overlap plus minus overlap. So positive lobe of psi A overlaps with negative lobe of psi B, or vice versa, reverse also it can take. So the resulting molecular orbital will have high energy than these two atomic orbitals. Let's take A and B, and because they have opposite chains, due to the repulsion between these nuclei, such type of molecules orbitals are called anti-bonding molecular orbitals. Because opposite charges, they will have repulsion, so they will form anti-bonding molecular orbitals. So one SA with positive lobe and B with a negative lobe combined together for forming sigma star we keep to show the anti-bonding orbital. So sigma 1s, and we can also represent, we have a nodal plane representing the repulsion between these two, and we can represent the addition overlap with sigma B, I told. So wave function B or sigma B, that is equal to wave function A plus wave function B. So for this, because it is minus subtraction, wave function A is equal to wave function capital A minus wave function capital B. So like this we can tell. So the diagram, energy diagram for this is, so when s orbitals combine together to form bonding molecular orbitals, so electrons enhance the bonding here, so because of addition property, constructive property, and electrons in the anti-bonding reduce the bonding because they are subtractive property or destructive property, and it is called anti-bonding molecular orbitals, and the energy is less here, it will become increased in the anti-bonding molecular orbitals. Why the energy is more needed here? Because of the repulsive forces present in it. So what are the conditions for the combining of atomic orbitals? So what conditions it should satisfy for the atomic orbitals to combine to form a molecular orbitals? As you know, first is the energy should be comparable. So they should have similar or same energy. Combining orbitals should have comparable magnitude of energy. In a homonuclear diatomic molecules, if we see, 1s orbital will not combine with 2s orbital. It will combine only with 1s. Similarly, 2p orbitals will not combine with 1s or 2s. So because they have different energies, so they should have same or similar energy, and the extent of overlap should be greater, so to build up the charge, and they have symmetry, same symmetry, like z-axis is taken as molecular, x and y axis are taken as perpendicular to the molecular axis. So like this we will take. So these are the conditions, very easy conditions. Similar or same energy, overlap, extent of overlap should be high as much as possible, and they should have symmetry. That's all, only 3 points. Then we will see how the overlap takes place between s orbitals, two s orbitals. Already we discussed it, because the example we took is s only. So when two s orbitals, 1s, so they have spherical shape. We know that s orbitals have spherical shape. They combine to form one bonding molecular orbital and one anti-bonding molecular orbital. So this combine to form bonding molecular orbital like this. So and represented by sigma 1s, and anti-bonding molecular orbital represented by sigma star 1s. So anti-bonding molecular orbital and nodal plane is there. So when the overlap takes place between two p orbitals, you see, so we already told z-axis we take as molecular axis. So 2pz orbitals, we already know that z we take as along the molecular axis. So when they two combine together to form bonding molecular orbitals psi 2p and anti-bonding molecular orbitals like psi star 2p. So and when we take 2px, so these are along the x-axis perpendicular to molecular axis. These also form two orbitals, molecular orbitals, bonding and anti-bonding molecular orbitals. So here, because they are not head-to-head overlap, they are side-to-side overlap, they form pi bond. So pi 2p and pi star 2p, and 2py also they will overlap together to form pi bonding molecular orbital pi 2p and anti-bonding molecular orbital pi star 2p. Like this, the three will take. So all together I constructed one energy level diagram. Let's see it. First, 2s orbitals, when they combine together to form bonding and anti-bonding molecular orbitals. So to form sigma 2s and sigma star 2s, and 2p orbitals, 2pz, first 2pz we took. So these two are 2pz. These two form bonding and anti-bonding orbitals, sigma 2pz, sigma star 2pz, here I wrote wrong. Then again 2px and 2py, because they are side to side interaction, they form pi bond, pi 2px, pi 2py, pi star 2px, pi star 2py. Why I am representing star? As you already know, anti-bonding will be represented with a star and bonding with just simply like that. So like this, the energy level diagram, and the energy will be increased with the anti-bonding molecular orbitals. Thank you.